Hello, class 11th physics, chapter mechanical properties of fluid. So today we discuss about some basic terms. First concept, fluid. So fluid is something which can flow. It includes liquids as well as gases. So these are the ways we can define fluid: the substances which have properties to flow, or the substance which can be deformed easily and unable to retain their shape under deforming force or stress or shear, whatever. So as I told you, liquids and gases both are included in this category. Next, types of flow. So there are different categories of type of flow. So we can say that steady flow, unsteady flow. So steady flow means, so in steady flow, speed of particles of liquid for a given region is constant, whereas unsteady, just opposite. So I'm writing opposite, means speed of particles of liquid fluid is a correct word. So maybe for the next in this entire video or entire chapter, I might be using the term liquid, but that should be considered as fluid. So if a speed of particles of liquid or fluid for a given region is not constant, then it is unsteady flow. But this is not over yet. Actually, we go beyond that and we consider a new kind of concept. So in a different manner, there are two other types of flow. So this is the type of flow in terms of speed. And now type of flow more microscopically. So a student often asks, what should we write if a type of flow is asked? So well, you can write this or this. Both will you will get for both you will get marks mm, microscopically. Okay, so we have two other types of categories. One is streamline, other is turbulent. So streamline flow. So, a streamline flow, the flow in which a particle of fluid follows succeeding particle with the velocity of succeeding particle. So, what does it mean? So, let us suppose there are two particles, one here and other here, and they are under this streamline flow. Then what is this streamline flow is all about? So, here, let us suppose this particle um, will now move along this direction. So, when this particle will reach here, it will also follow this path. And so so if it is the path, so if this particle A is moving this way, then this particle B will also follow the same path. It will come at A, it will go to this C to D, so it will follow the same path. So this is called streamline flow. Turbulent flow, we can say a flow which is not a streamline. So we can say flow in which particle of fluid are not in organized manner. So here it is essential to define a streamline. It resembles with that magnetic field line type of concept. So the taken path actually by a fluid particle under steady flow. So it is related to, actually streamline flow is related to steady flow only, is called a streamline. Actually streamline is completely uh, you know a single term. All right, so this is streamline. So there can be different type of streamline, like this, uh, like this, depending upon how liquid is flowing. like this. This is also possible, depending upon how liquid is flowing. Next is properties of streamline. So number one, tangent to a streamline at a given point shows velocity of particle at that point. Like if this is a streamline, so if here we draw a tangent, so that tangent will show the direction of velocity. However, it is continuously changing. Velocity is changing. We know velocity is associated with direction also. So direction is changing, so velocity is changing. But at this point, we know the velocity is this. And that is why while defining streamline flow, I use the term velocity. So this particle when reach here, it will also have the same velocity, same direction. Later on, direction will change due to some other reason, some external reason. So two streamlines do not intersect each other, and we know why. If they do so, there will be two direction of velocity, which is not possible of a single particle. There will be two direction of particle velocity. So this is not possible. So there can never be intersection of two streamlines. And yeah, of course, it shows the direction of flow. In which direction liquid is flowing. But the discussion is not over yet. The question is, if we are talking about streamline flow, so for entire liquid or entire fluid, um, is this concept applicable? Let us imagine a river. So top of the river, the water at the top of the river flows faster, whereas if we go with the depth, it flows slower. Same thing you can do in a bucket full of water, and you wave your hands. You wave the water, make a whirlpool here. It will look like this. Right now I'm not doing it. I will do all these activities in a separate video. Then you can see that the water at the upper region will have greater velocity than the liquid in the lower region. So it means liquid will have different velocity in different regions. So at that time, how this streamline flow law is applicable, because now there will be different type of flow here, different type of flow here, and different type of flow here. So in such cases, if we take liquid in a bulk, um, in a huge amount and with some appreciable depth, then we divide that liquid into different layers, and we consider that these layers are not intermixing layers. Then a modified form of streamline flow is called laminar flow. It is a type of flow in which there are several layers. I'm writing it pointwise. There are several layers, non-intermixing actually, non-intermixing layer. See, to study fluids, we have to make these assumptions. Second thing, each layer is in streamline flow. With their local steadiness. What does it mean? Actually, local steadiness, this entire layer will have different velocity than this. But this entire layer will have velocity, let us suppose 5 meter per second, then entire layer has that 5 meter per second. If this is 4 meter per second, then entire this layer has 4 meter per second. So this is laminar flow. And now how can we show it pictorially? Like this. Why a shorter one? Because this time these layer length shows their relative speeds. This entire layer is in streamline flow, so also this, so also this, so also this. But they have their own steadiness. And if we just highlight on these individual layer, so this entire layer will undergo streamline flow. So what are the examples of such kind of flows? So streamline flow is like you can see rivers in the plain region. So those rivers looks still, as they are like water is not flowing, but actually water flows. And if you closely look at that, then you can find that, of course, from a particular region, water is flowing with same speed and in same direction. And if we talk about laminar flow, so it is very well seen in honey flow. If you tilt the bottle of honey, then it's different layers. So you can see they flow with different velocities. So that's all in this video. More of this chapter coming up. And I will upload another video for activities related to these streamline flow, laminar flow, and turbulent flow. Stay connected.